So if you caught the previous, the last video, the last episode, you know that I'm kind of trying to figure out wiring layout stuff, and in order to do so, I'm trying to at least go back to where I was 2 years ago with the sensor management. So in the last video, we got the sharp infrared sensor working, and we could measure distance from rover's nose, which is pretty cool. The other set of sensors that I had tested 2 years ago were infrared sensors of a different sort for remote control. So basically the idea that I had, which I think is pretty cool, was to take something like the Apple TV remote and be able to perform some rudimentary functions for rover. Theoretically even control his driving, but that's the driving stuff I kind of want to be more semi-autonomous. But there's other stuff that could be done, and just having the ability, the option to control rover remotely through a device like this, which is actually a pretty nice design, gotta give it to Apple, is pretty neat. So let me show you what the sensors looks like. You can see they're two little tiny gizmos. We're going to connect up the receiver first, because before we can send something, we need to know what it is that we're sending. So the idea would be to record the signals. So the way it works is whenever you click a button on a remote control, it sends a different code, a different IR signal / code through the little window. And we want to receive that and record that so that when we send out a code, it basically matches up. So for example, if we wanted to theoretically turn on the Apple TV, we'd need to know what code to send for the Apple TV to recognize that we're actually asking it to turn on. That's the idea. So yeah, let me show you what the actual setup on rover looks like for the receiving, the IR receiver module. So pretty basic stuff. We've got the receiver module here, wired into the number 2 pin on the Arduino, getting power through the Arduino as well, but just through using the breadboard. And that's pretty much as simple as it gets. Let's take a look at the code. The code is pretty simple, as you can see. We basically specify, most importantly, we import the IR remote library. We specify the receiving pin, and then basically we just wait to receive a signal. So let's upload this. And there we've got the Arduino flickering. Let's flip over to the serial monitor. Okay, so all I'm going to do right now is just point the Apple remote that I showed you a moment ago, and I'm clicking the up button. So from what I understand, this is very typical that you can get mixed signals. So it's not consistent. You can definitely see pattern. Let's see if I adjust the position. Okay, so this is still up. This is down. Okay, I'm a little confused. I'm just kind of flipping back and forth through up and down, but as you can see, we're getting very inconsistent readings, and I'm not sure why. So let me do a little digging around, and I'll follow up with you guys. So I did a bit more reading, and first off, I thought maybe it had to do with frequency. So apparently there are a few different, but there are 2 common frequencies used by remotes. 38 kilohertz and 40 kilohertz. So I thought maybe there was a mismatch because I looked it up and my receiver module is 38 kilohertz. So I thought maybe the remote was 40 or something else, the Apple remote. Fortunately, I came across another person who had the same sort of idea, wanting to kind of create a multifunction remote and take this readings off of the Apple remote using an Arduino. And their suggestion was to use this sketch that you see here, the dump example. And it just provides a lot more detail as to what the Arduino is seeing. So for example, if I hit the up button on the Arduino again here, I'll point out here, it says decoded NEC and the 77, etc., etc. So we ignore the other stuff, but I hit up again and it was consistent with the same value. Now I'll hit down. And the only difference is this middle letter. Instead of D, it's now B. So if I hit up again, I get a D value. So basically, we now know the values for up and down on the Apple remote, which is pretty great. So we could then essentially read in the other values for the different buttons on the remote. And once we know that, we can program that into ROVer. We're now able to read the codes off of the Apple TV remote, which I think is pretty cool. I mean, I don't know what I'm going to control as far as ROVer's capabilities with the remote. I don't think I'm going to use it for, well, I shouldn't say that. I don't know. But I think it'll be cool to have it as an option. It's a tiny little remote. It looks cool. It's also aluminum, like ROVer. All things that matter a lot. But in any case, so we've got that figured out. I haven't connected yet the transmitter, so I'm going to do that. Not that there's any point in doing it yet for functional reasons, but more so just to understand where the wiring needs to go. Again, there's really just a 3-wire harness, ground, 5-volt, and the signal wire. So I just need to understand whether that's a digital or analog pin on the Arduino, and how that affects the other pins that I've used up or left open. But otherwise, that's where I'm going to leave the sensors for now. I've got ultrasonic sensors as well to play with, but we'll tackle that later. Right now, actually, I kind of remember that I may have tested those as well. So I may have to connect one of those to see what wires it requires. Somehow I remember it requiring more wires. So maybe that's going to be the next step. Okay then. So if you're interested in ultrasonic sensors, follow up for the next video. Until then, cheers.